Hello, today we are going to learn about finite differences with quadratic sequences. First, we want to look at three types of equations. There's linear equations, which are y equals ax plus b, quadratic equations, which are y equals ax squared plus bx plus c, and cubic equations, which are y equals ax cubed plus bx squared plus cx plus d. Now, when we have a table of values like this, or this can also be written uh, um, if we just had 3, 5, was it 11, 21, 35. It could also be written like this, and we could do the same thing. But it's nice when it's in a table like this, so you can see how it lines with term 1, term 2, term 3, term 4, and so on. So now what I like to do is I like to write this vertically, because it helps us keep this in order a little bit better. So what I'm going to do is, first thing I want to do is find the differences. Between 3 and 5 I go up 2. Between 5 and 11 I go up 6. Between 11 and 21 I go up 10. And between 21 and 35 I go up 14. Notice how these are not constant differences, so we know that the function is not linear. So now we take the second differences. I'm going to go up by 4, up by 4, and up by 4. Since there's a constant second difference in my sequence, I know that this is a quadratic sequence. So now I want to look at how I can use finite differences in order to solve this for the explicit formula. Now I'm going to make um, a table or something like this, but I'm going to do it for algebraically. Now you know that this is term 1, term 2, term 3, term 4, and term 5, and so on. And our goal is eventually to find the exclusive formula, which is our nth term. Well, what we're going to do is we're going to do this 1, 2, 3, 4, 5, all the way up to our nth term. But we're going to use the general equation for a quadratic, which is an squared plus bn plus c. What's nice about this chart that I'm going to create right now is we can use this chart for every single quadratic equation. All right, the first thing we want to do is plug in n equals 1 into this equation. So that would be a times 1 squared plus b times 1 plus c. Well, 1 squared is 1, so 1 times a is a. B times 1 is b, and then we're going to add c. Now if I put a 2 in here, my term is 2. 2 squared is 4, so 4a plus 2 times b is 2b plus c. If I put a 3 in there, that would be 2 times, should just erase that, be a times 3 squared plus b times 3 plus c. So 3 squared is 9, so 9a plus 3b plus c. And if we continue that, we'll get 16a plus 4b plus c, and 25a plus 5b plus c. Now we're going to want to take the difference of those values. So the difference is here. 4a minus a would be 3a, plus 2b minus b would just be 1b, c minus c is 0. Take the difference here, we'll have 5a plus 1b. The difference here would be 7a plus 1b. The difference here would be 9a plus 1b. Now, we can take the second difference. So if I take the difference of these, I'll get 2a, 2a, and 2a. All right. Now I'll erase this down here. I'm going to draw a line just to separate the information. Now this box to the right of my line, I don't like this. There we go. My box to the right, we can use for all quadratics. This box to the left is specific to this problem. So once we have this side in our notes, we don't have to keep doing this again. All right, so now we want to find our equation down here. So um, if I look at this 4 is in the same position as 2a is over here. So the equation for this is 2a. So 2a is equal to 4. If 2a is equal to 4, we can divide both sides by 2, so a will equal 2. Great, we already have our a. So we can start our equation, 2n squared. So let's choose another color. Let's choose green. So if I know a is 2, then I know, if I look up here, 3 times 2 plus b. So 3 times 2 plus b. Now we have to think what matches this spot over here. Well, that's in the top position on the second column. So that's going to equal 2. So 3a plus b is equal to 2. So 3 times 2 is 6. 6 plus b equals 2. So if I subtract 6 from both sides, b is equal to negative 4. Now let's pick one more color, red. And I know my a, I know my b. Oh, since I know my b, I can say minus 4n. Now I just need my c to finish this equation. The equations with c are all in my first column. So a plus b plus c is going to equal 3. Well, I already know my a is 2, my b is negative 4, c is going to equal 3. 2 plus negative 4 is negative 2. Add 2 to both sides, and my c is now 5. So 2n squared minus 4n plus 5 is my equation for this function. Now if I want to find the 20th term, it's going to probably be a big number. We got to put 20 into this equation. 20 squared is 400 minus 4 times 20 plus 5. Well, 2 times 400 is 800. 800 minus 80 would be 720. 720 plus 5 is 725. And my n would be, I don't even think I can write it in this box, 2n squared minus 4n plus 5. All right, I hope that helps.